Okay, so today we're going to be talking about electrical charge and electrical force. So basically it's static electricity that we're kind of talking about. So when you're a little kid, sometimes kids like to rub their shoes on the ground and then touch someone else and shock them. Or if you get out and you're riding down a slide and you get shocked, that's static electricity. So our first definition is electrostatics. Sounds pretty cool. So this is the study of electrical charge that can be collected and held in one place. So electrostatics, study of electrical charge that can be collected and held in one place. So I'm going to draw an example. This is supposed to be a comb. Yeah, so like a hair comb. Not bad. We all know my drawing abilities. So this example, we're going to have a little bit of pieces of paper down here next to the comb. This is the example in the book. Most people don't have pieces of paper next to their comb that they brush their hair with. But if you rubbed a comb through your hair, it's going to transfer electrons, giving the comb a negative charge. And if you had pieces of paper next to the comb and you brought the comb next to the pieces of paper, charge separation is going to be induced, and this is going to cause the paper to move upward and attach to the comb. It's going to move up against the force of gravity. So you could make pieces of tissue, paper rise. So that's just an example of charge separation. So there are three fundamental properties you need to know about charges, and this should be review. Most of you should already know, hopefully all of you, that like charges repel. So this would be like a positive and positive charge, or a negative and negative charge. The second is that opposite charges attract. And then the third, which is obvious, if you have a positive and a negative charge that are equal, they're going to balance and they are neutral. So hopefully you remember these from chemistry. So when you have charges, you can also have separation of charge. So this just means that if two neutral objects are rubbed together, they can become charged. So the example we have is a rubber rod and a piece of wool cloth. So if both of these have the same charges, and they're equal, they're neutral right now. There's 3 positives on each and 3 negatives on each. So if you rub them together, if you rub the rod with the wool cloth, electrons are going to be removed from the wool and cling to the rubber rod, and both objects are going to become charged. So the total charge combined is going to remain the same because charge is conserved, just like we talked about with thermodynamics with energy. Individual charges are neither created nor destroyed. All that happens was that positive and negative charges were separated through transfer of electrons, but the overall charge would remain the same. So an example of this in real life that you probably experienced but didn't know would be contact between car tires and the road. This can cause a separation of charge. So while you're driving, between your tires and the road, electrons are being removed and transferring. So besides driving to go get McDonald's or something, you're also separating charges. So now we're going to talk about two types of material that can influence charges. And the first one is called conductors. And conductors are materials that allow charges to move about easily. So examples of these would be metals, so like copper, aluminum, plasma, graphite. You don't have to know all those examples, you just need to know that metals, these are metals. Metals are one of the main conductors. So a picture of this. So say I have a plate and I place some charges on here. These charges are free to move about wherever they want pretty easily, so they can go, if they decide they want to move to the middle, they can go there. So they can roam around the plate and move about easily. And the next one is insulators. And these are just the opposite of conductors. They do not allow charges to move easily. So they are materials that do not allow charges to move about easily. So examples for an insulator would be like glass, plastic, cloth, or dry air. So this time if I had a plate and I decided to place a charge right here, they're going to stay wherever I put them. They're not going to be able to move around easily. So they have to stay put. They're bound to wherever they are placed. Unlike conductors, which allow the charges to move about freely. So I think of like conductors as like us, and insulators is like if you go to prison, you're like stuck there. We can move about, do what we want. Insulators, no. You're stuck in that one place and you're not allowed to leave. So there is one exception of an insulator, which is air. Under certain circumstances, air can become a conductor. And I'm sure you can guess what this might be. So when you're a little kid, most little kids get really afraid of lightning and thunderstorms. So that's our example, thunderstorms. So during thunderstorms, there's a discharge between the air and the thunder clouds that are moving, and then electricity or electric thunderbolt is discharged and comes down to earth. So this is the only time that air becomes a conductor instead of an insulator, which is a good thing because we don't want bolts of lightning coming down every day. So that's it for electrical charge. Now we're going to briefly talk about electrical force. An electrical force is just the attractive or repulsive interaction between any two charged objects. So there's different properties of forces, and we can talk about forces on charged bodies. So most of this is just common sense again, or things that you should have already learned. So number one, force is stronger when charges are closer together. Number two, like charges repel, like we just talked about, and opposite charges attract. And number three, charges exert a force on other charges over a distance. So this just means that charges can influence each other and apply forces on one another. So I'm going to draw a picture example of this. When we get back from break, we're going to do like a little activity where there'll be 3 different stations where you'll work with static electricity and see what happens when you rub different objects together. So say I have a rod which is attached to a pole and it can rotate. This is going to have positive charge. This is going to be an example of same charge. And if I have another rod that has the same charge, so it's also positive, or it could be negative and negative. If I bring it close to my rod that can rotate, they are going to repel, and it's going to make my rod rotate counterclockwise. Now, the opposite will happen with opposite charge. So again, we're going to have a rod attached to a pole that can rotate. And we'll do an example of this at one of the stations when we get back from break, so you can actually see it. So say we have a positive charged rod, then I bring a negative charged rod close to it. They're going to attract. So this time it's going to move clockwise. So our last thing we're going to talk about is two ways that you can charge neutral bodies. So the first is charging by conduction, and the second is charging by induction. So first we'll talk about charging by conduction. And this is just charging a neutral body by touching it with a charged body. So actually we'll call the body an object. Touching a neutral object. So charging a neutral object by touching it with a charged object. So I don't have a picture for this, but your book does, so you can look it up in your book. But basically, if you had a neutral object, so say you had the same amount of positive and negative charges on a plate, and you brought a rod that had positive charges, and you touched your plate that was neutral, it would cause the plate to become charged. And our last one is charging by induction, which is just the opposite of conduction. And this is when you charge a neutral object without touching it. So I do have a picture for this one. So the first step, so say I have two plates next to each other. They're going to be touching. So these are two neutral plates. They have the same charges on both sides. So then I'll bring a charged object close to the plates, but I'm not going to touch the plates. So let's say we're going to make this rod negative. Our negatively charged object is a negatively charged rubber rod. That's going to cause the charges to move. So to the plate on the left, all the positive charges are going to move because they're going to be attracted to the negative charge. And on the right side, all the negative charges are going to move because they're repelling. So I don't know if you can't see it very well, but these aren't touching. It's really close, but they aren't touching. So then if I remove the rod and I separate the plates, we're just left with a negatively charged plate and a positively charged plate. So that is charging by induction, charging the neutral object without touching it. So this side becomes negatively charged and this side is positively charged. So that is it for our lecture on electrical charge and force. These are just the basic concepts that I want you to review and remember from chemistry that you should have gone over before. This is setting up the fundamentals of the rest of this section of our unit. So when we get back from break, we'll start talking about Coulomb's law, which there'll be equations for, and then voltage, DC circuits, resistors in parallel and in series. So this is just fundamental knowledge that'll help build a basis for that we'll build upon later.